So this is a video of my Hewlett-Packard HP67 programmable calculator. I used this calculator back in college in 1980 doing electrical engineering, and I thought to share some memories and some features of this calculator. So I had to work, like, I remember, a full summer to save enough money to buy this calculator. It was around $400 or so, and in today's money, you're talking the price of a nice laptop. Anyhow, so this calculator was used in courses that included in electrical engineering circuits, numerical methods, and design, like in circuits, the design of filters. So the calculator came with packages: math, business, electrical engineering, mechanical engineering, games, statistics, you just name it. And each package came with a manual and a bunch of programs on magnetic cards. Here's this one is setting up a 4x4 matrix, solved by 4x4 matrix, and so on, finding the zeros of f of x equal to 0, differential equations. This describes numerical integration using trapezoidal rule and then Simpson's rule, and it'll show you how to use the programs. So essentially, and in electrical engineering, this is the pack for the EE pack. And here's an example of designing a ladder type passive filter, either high pass, low pass, of the Butterworth or Chebyshev type. And again, it came with the package. And here you see the magnetic cards. And this is a bunch of programs I created myself and I used in various classes, and some of them just for fun. So you could buy those blank. This has to do with some filter design. I don't have the full documentation of the programs, unfortunately, so some of them I have to go back and spend hours to learn how what they do and so on. So this is Butterworth filter design over here, those cards at the bottom. So what I'm going to do now is just to show you how a program can be executed on this calculator, and I'm going to choose something that I wrote early on, a very basic transformation, delta to y or y to delta. Those are resistive configurations. In trying to reduce a network of resistors, sometimes you're stuck with a delta or a y, and you want to transform a delta to a y or the other way around to be able to simplify or to reduce the network of resistors. So essentially, there are a set of equations. Here's the y to delta transformations that typically you learn in circuits, basic circuits. And those equations are programmed on, in this case, formulas, if you like, nothing fancy in terms of programming. And this is a magnetic card that has those formulas programmed on it. And I'm going to demonstrate this example now on this calculator. So we're going to switch it on, and you take the card and you put it in a slot, in a side slot, that lower one there. It'll go through, and then success. So you can take this card and you can put it back because it has instructions on the keys, which ones to push. Okay, so A, B, C keys would enter the R1, R2, R3 from this delta. So we'll have like 12, 24, and 36. So we'll put 12A, 24B, and 36C, and now I just push the delta to Y, and it should give me basically the 6, 4, and 12 in some specific order. There's the 6, the 4, and the 12. Okay, so this is a cool calculator. They tend to develop a problem reading the card. It's called the gummy wheel. So the mechanism that pulls the card has a rubber wheel that over time deteriorates and it won't pull the card. So those need to be fixed, and I did fix it on this calculator. So memories from 42 years ago, and this program was written about that long ago. I hope you enjoyed it, and take care now.